Hi there, this is the second video about the usage of the Laplace transform to solve circuits. So let's crack on and draw our new circuits that we're going to use as an example. Right, so we're going to have power supply here, so a different of potential. Then we're going to have a switch, and then we're gonna have a resistance, then an inductance, and then a capacitor. There we go. Okay, so this is going to be our circuit. So let me just write t equals 0 at the time in which it's going to be closed. I is going to be our current, I of t. This difference of potential is this generator with just 1 volt. This resistance is going to be 3 ohm. This inductance is going to be 1 Henry. And this capacitor is gonna be, I don't know, 1/2 farad. Okay, so in this circuit, the switch, let me just write the switch is open for t less than 0 and is closed at t equal 0. Let's suppose that the capacitor is discharged at t equals 0 minus. Find I of t. Okay, so this is basically a problem, one of the classic problems you can actually find when you're dealing with the Laplace transform. So in this problem we basically have this circuit here, and it's basically telling us that the switch is actually open and it's going to be closed, and therefore the current is going to flow at t equals 0. So for t less than 0, the current is 0. So for t less than 0, the current is 0 because it just opened. So we need the closed circuit in order for the current to flow. So we can actually say that I of 0 minus equals 0. Now, in the circuit, since we have to use Laplace, we're gonna draw the equivalent circuit of Laplace. And in the equivalent circuit of Laplace, we're gonna have the inductance, which is gonna be the resistance. The resistance is still gonna be a resistance, and the capacitor, since it's initially discharged, so it doesn't have anything in there, it doesn't have a charge. So since it's initially discharged, it's just gonna be a resistance. So let's just write our equivalent circuit of Laplace. So this is gonna be my generator, plus minus. The current is gonna flow this way. This is gonna be my resistance. So this one is still gonna be this one. Now we're gonna have the inductance, which is turned into resistance. And then we're gonna have the capacitor, which is discharged, so it doesn't do anything. So it's gonna be a resistance as well. There we go. There we go. So it's 1 volt. So in the equivalent circuit of Laplace, our generator is going to be 1 over S. This is 3 ohm, so it's still going to be 3 ohm. This one is 1 Henry, so S, because it's S times 1, so S. And this one is 1/2 farad, so it's 2 over S, because we just flipped the denominator to the numerator. Okay, so now we're just gonna say that all those summed together are gonna be equal to 0, because it's one of the fundamental things about circuits. So we would have 3 I of S. Now we're going to find everything in terms of S. So plus S I S. So 3S. Yeah, 3IS is the resistance. Plus S is the inductance, which is now resistance as well. Plus 2 over S, which used to be the capacitor, which is now resistance. IS. Minus, well, this one, which is the power supply, 1 over S, equal to 0. So now we can basically find, well, we are just gonna, our target is to find I of S, so we're just gonna multiply I of S times, what do we get? 3 plus S plus 2 over S equal to 1 over S. I just got the 1 over S on this side. Okay, so this is actually going to give us I of S times 3S plus S squared plus 2 everything over S equal to 1 over S. Okay, so we've just found I of S, which is just 1 over S squared plus 3S plus 2. Okay, so now that we got to up to this point, we have to find the roots. So in order to find the roots of this polynomial, you can use delta. It's fine if you use delta of S squared plus 3S plus 2. But I mean, come on, you can actually, you're a mathematician. You can, if you're watching this channel, you're either an engineer or a mathematician. So you can basically see that the two roots are S equal to -1 and S equal to -2. So we're just gonna say that S, first root is gonna be -1 and S is gonna be equal to -2. You can you can try it, but because you know this one will be same as saying S. I'm sorry, 1S plus 1 times S plus 2, and you will get the same thing, S squared plus 3S plus 2. So the two roots are those two guys here. Okay, so now that we have the roots, we're going to try to find the poles. And the two poles, we're gonna apply the same clever trick we did before. So we're actually gonna write down this guy here, but we're gonna multiply this guy here at the denominator by s plus 1, and then we're gonna substitute the first value that we have found. So this will be 1 times s plus 1, so this guy here, over those two guys here. So s plus 1 times s plus 2. So those two guys cancel, and we end up with 1 over s plus 2. So now we substitute s with -1, so we will get 1 over -1 plus 2, which is just 1 over 1, which is just 1. So now if we go on, we do the same thing by using this guy here. So it's going to be 1 times s plus 2 over those two guys here. S plus 1 times s plus 2. So those two guys cancel, and we end up with 1 over s plus 1. So now we substitute the value of s of the second guy, so -2. So we get 1 over -2 plus 1, which is just 1 over -1, which is just -1. Okay, so now we have found I of s, but all we have done was needed because we have to find I of t, which is required, which the problem just asked us to find. So we're going to use the anti-transform of Laplace in order to get from I of s to I of t. So now I'm gonna use the anti-transform of Laplace to get from I of s to I of t. Okay, so I of t, which is what we need to find, is actually just, as we said, the anti-transform of Laplace, so L to -1, of this guy here that we have just found. 1s2 plus 3s plus 2. So I of t is actually equal to, well, this guy here is 1, so it's just 1 times e, so e raised to the power of -1 times t, so -t. We have a minus because it's -1, second one, so we get the minus. E raised to the power of -2 times t, so -2t. And that's it. This is just the I of t that the problem just asks us to find. And as you can see, it's not, Laplace scares the hell out of many students. I mean, honestly, it does. But it's totally fine. I mean, it's not just a big deal. You can find it. Just the whole point is just you have to, well, first of all, understand the problem. Otherwise, you're not going to be able to solve it. And then you have to write the equivalent circuit of Laplace the correct way, keeping in mind that resistance are going to be resistance, inductor are going to become resistance, and capacitor are going to behave differently according to their initial status. So in this case was discharged, so it just became resistance. If it was charged, then it would have been a resistance plus a difference of potential, so basically a power source, because it would have been acting like a power source. But that's not the case. So then we basically said that all these together are gonna be equal to 0, and we subtracted the generator, of course. We found out I of s. Then we found out the root. You can use delta here and do, you know, delta negative b times blah 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 blah. But you know, you can basically see that these polynomial is just s plus 1 times s plus 2. If you don't believe it, just try to calculate it, and you're gonna be back to here where you started. So now that you find this, you can basically see that the two roots are s equal to -1 and s equal to -2. So once you find the root, you gotta find the poles, and to find the two poles, you have to apply this clever trick, as I said. So you basically take the whole thing, the whole I of s, and you multiply the numerator by the first guy, and then you substitute the s by the value of the first root, and then you do the same for the other one. And those things are going to be necessary because so that you can actually write the correct anti-transform of Laplace to get IT from I of t from I of s. So that's pretty much it.